Welcome students. Welcome you all in lecture number 7 of unit 4, that is fuels. And in the previous lecture we discussed about solid fuel sample. Our today's topic is liquid fuels, and in liquid fuels we will discuss about the refining of petroleums. Basically petroleum is nothing but the crude oil, and if you consider, this is very important primary liquid fuel sample. It is dark colored viscous oil that found deep in the earth crust. So to form the petroleum, number of millions of years will be required, and this process will be carried out in the anaerobic decay of plant and animal life under the influence of high temperature and the pressure. So for the formation of crude oil or petroleum, we require a number of years as well as we require high temperature and pressure. So if you see, this is mainly consists of a complex mixture of hydrocarbons like straight chain paraffins, cycloparaffins, olefins and the aromatic compound. Along with this, it consists of the other organic compound also, which containing nitrogen, oxygen and sulfur, as well as traces of the inorganic compounds. And if you see, the average composition of this crude oil is carbon is around 83 to 87% is present in the crude oil. Hydrogen is around 11 to 15%. Sulfur, nitrogen and oxygen is around 0.1 to. Now what is this refining process? In the refining process, we separate out crude oil into the different fractions. So this is the process of separation of the crude oil or the petroleum into different useful fractions on the basis of their boiling points by fractional distillation process. So we use here fractional distillation process, and basis of the boiling point we separate out all the fractions along with the impurities also. So impurities also going to separate out in the petroleum refining process. But this refining process is carried out in the 3 steps. Okay, if you see, the first step is separation of the water. See, crude oil is an emulsion of oil as well as a water. So water is also present in the crude oil. We need to be separate this water from the oil, and that process is called as the de-emulsification process, because that mixture is present in the emulsion form. So for this purpose, we pass that emulsion through the highly charged electrodes. So whatever the colloidal particle get combined, it will be forming one big cloud or big drop, and that drop gets separated out from the oil. So your first step is the separation of the water. Second step, that is the removal of sulfur compounds. So the harmful sulfur compound is also present in the crude oil. We need to be separate this harmful sulfur compound from the crude oil, and for that purpose we add a copper oxide in the crude oil. So that copper oxide is going to react with the sulfur compounds. It forms the copper sulfide precipitate, and this precipitate then filter it. After the filtration process, that sulfur compound gets removed from the crude oil. And then the third step, that is a very important step in the refining process, is fractional distillation process. So as a crude oil is a mixture of hydrocarbons, so these hydrocarbons get separated out based on the boiling point difference. So the main principle behind this fractional distillation is higher boiling point component first condense, while the lower boiling point component condense last. So by using this principle, we can separate out different useful fractions on the basis of their boiling point difference. So this is the diagram that we use in the refining process, or this is called as the fractional distillation process. So here this is called as a heater, or we called as a furnace also. This furnace is connected with this fractionating column, or it is also called as a fractionating tower. The height of this tower is around 30 meter, and if you see, the diameter is around 3 meter in the diameter. So if you see, these are the horizontal trays are arranged here. Around 50 to 60 numbers are present in one fractionating column or one fractionating tower. The furnace temperature is around 450 degrees Celsius. Bottom temperature of the tower is around 400 degrees Celsius, while the top temperature is around 40 degrees Celsius. That means here the temperature is gradually going to decreases from bottom to top of the fractionating tower. So we have this bubble curves. Through these bubble curves, whatever the uncondensed gases, that will be going in the upward direction from bottom to the top position. Along with this, if you see, this outlet is there. We will collect the fractions by using this outlet to the fractionating tower. Now we will see the working of this fractional distillation process. First, crude oil will be entered in this furnace where it will be converted into the vapor state. Then that vapor state, it will be entered in the fractionating tower where the bottom temperature is around 400 degrees Celsius. So as I mentioned earlier, according to the principle of this method, higher boiling point component first condense in the first tray. For example, this is the first tray and it will be cooled and then it will be collected by using this outlet. So for example, first fraction is a fuel oil which is having 350 degrees Celsius temperature. Now the next higher boiling point component will not be condensed here, it will be in the uncondensed form, that will be goes in the upward direction by using these bubble cups, and then gradually it get cooled down in the second tray, and after cooling process it will be separate out, it will be collected by using this outlet. So by using this same manner, we can separate out the different fractions by using or based on the boiling point difference in the different type of the fractions. So if you see, the first you will get this fuel oil around 350 degrees Celsius, second lubricating oil 300 degrees Celsius, diesel 260, kerosene 180, naphtha 120, petrol 70 degree. And at the end, for the top of the fractionating tower, we have the uncondensed gases. It is having the mixture of hydrocarbon up to C1 to C4, and that can be used to prepare the LPG gas, like liquefied petroleum gas, and this will be used as a fuel. So if you see here, the uses of all these fractions are given, like lubricating oil, which is for the cars and other machines, diesel, it is for the diesel engines, kerosene, that is for the jet fuel, paraffin for the heating and lighting purpose. So the same process I express here also. First, the crude oil is heated at about 450 degrees Celsius in the furnace to convert it into the vapors. Now that vapors travel upward the bubble cups, gradually gets cooled. The organic compound with a higher boiling point get first condensed and then liquid deposit on the tray. Then whatever the remaining uncondensed vapors get rise up, get condensed turn by turn on the upper bubble cups. So in this way, we can collect the fractions like petrol, diesel, kerosene, heavy oil from the small bubble trays, and then finally the small part of vapors which comes out as the uncondensed gases that I mentioned that we use to prepare the LPG gas. So these are the few fractions that shown in the diagram also. These are the fractions which collected in the refining of the petroleum process. One more thing, it is possible to convert the any higher boiling fractions into petrol or LPG, and that process is called as the cracking process. Now what is the main objective of cracking? It is to obtain the greater yields of the gasoline by the thermal decomposition process of heavier fractions. And what is this cracking? In simple language, this is a process of decomposition of the higher molecular weight hydrocarbons into the lower molecular weight hydrocarbons. So we can say higher boiling point component gets converted into the lower boiling point components. And what happens in this cracking process? It involves the breaking of carbon-carbon or carbon-hydrogen bonds. Along with this, it produces some alkanes as well as alkenes. and a small amount of the carbon and hydrogen are lost. So this is a known example of cracking decane, that will be converted into the pentane and pentene by the cracking process. So breaking of the higher hydrocarbons into the lower hydrocarbons. And this cracking we can do by using the two processes. First, that is thermal cracking process, and the second is the catalytic cracking. So thermal cracking, it carried out at the high temperature and pressure in absence of the catalyst. So for the thermal cracking process, there is no need to use the catalyst, while in the catalytic cracking, it will be carried out in the presence of catalyst, and at much low temperature and low pressure will be required for this process. So this is about the refining process. In short, refining process or refining of petroleum or crude oil, it involves separation of the different fractions, which based on the fractional distillation, or which based on the boiling point difference. Along with this useful fractions, we can separate out the impurities also.